Words into Symbols Day 2 is where we're going to start today. If you all have your textbooks open, I'm going to go through page 16 and I'm going to go through as many as I can in about 15-20 minutes, okay? Let's see. Trying to decide how I want to do this. Okay, so I'm going to start at oral number 9. Yes. Take the blue pass. You're going to miss notes, though. You'll have to get them copied. Oral number 9, first one. A rectangle has a width of 6 units and a length of x units. Guys, did we do examples 3, 4, and 5? I don't think we did. All right, so before I do this, cross that off. We're going to do the examples. I apologize. My notes are, I wrote something that I should have clarified. Examples 3, 4, and 5. Okay, so today we're going to cover examples 3, 4, and 5. So here's example 3. Find the area and the perimeter. Mine's going to be different. Find the area and perimeter of a rectangle. And here, remember, it's different. It's not going to be what's in your book. So with a length that equals 5 and a width that equals W. Huh? Well, bear with me. Let's sketch it out. And again, the sketch does not have to be anything awesome. It simply has to illustrate, if you use a sketch, what you have. Area is length times width, right? And perimeter is all of the lengths added to all of the widths. In other words, sides, so that would be 5 and 5, and that would be W and W, right? Let's start with area. If area is length times width, how would you indicate that using the information you've been provided? Any ideas? What do you think? If this is length and that's width, what's area of this shape? Go ahead. She's right. 5W. Exactly right. And if perimeter is the sum of the sides, Jay, what do you think perimeter would be?
5W?
Nope, that's length times width, right? Area. We're looking for perimeter. Perimeter is what? The sum of the sides, just like a normal perimeter. Sum means add.
10.
10, okay.
10W.
Nope, that's, you're doubling this and then multiplying by that. It says sum.
Oh,
So what's this?
5.
And sum means do what?
Add.
So 5 plus,
W.
plus,
5.
plus,
W.
awesome. So 5 plus W plus 5 plus W is what my friend Jay just said. Now, is that simplified in simplest form? In other words, everything's combined? Lizzie, how would you combine that? Good, so 5 plus 5 is 10. What's 1W plus 1W? Nope, 1W plus 1W is 2W. Good. And there's your answer. That is it in a nutshell. And the example 3, you can think of it this way, using that. And you can even think of it as saying perimeter is the same as 2 of the lengths added to 2 of the widths, because that's what that is. LL is 2 of them. WW is 2 of them. Since we don't have a numeric value for width, it looks like that. That's example 3. Example 4, their example 4 deals with cost of, what is it, pizza? So cost of pizza is going to be what they're dealing with.
I'm taking DT, right? I'm taking silver. Or no? Yeah, that's fine. That's fine.
Yeah, for sure then.
Yeah.
Okay. Pizza. So what we're learning about cost is the cost of an item is equivalent to the number of items, so the number, just using that, multiplied by their price for each one. Okay? The cost you pay for something is equal to how many of the somethings you bought multiplied by the price of each one. You and your friends buy 2 pizzas. We're not going to do that one. We're going to do something else. We buy 4 burgers costing B each. And fries costing F, and 2 fries costing F each, because they're really big fries. I went to this place last weekend that had fries and the thing was like this big. I mean, it was this huge thing of fries. I couldn't even touch it, it was so huge. So if I buy 4 burgers costing B each, it's the number times the price. 4 times B would be my burger cost, right? But that's not the only thing I bought. I also added to my purchase by buying 2 fries at F each. Remember, these letters are just representing something. Adding these two things together simply results in 4B plus 2F. The result is not 6 of anything because their costs are different. We don't know what their costs are, but because my story problem tells you that you buy 4 burgers at B each and 2 fries at F each, they've told us in that story problem that it's a different price. Otherwise, they would have given us the same variable. Okay? That is my example 4. So far we've dealt with area perimeter, found at the top of page 15 in bold. We've also dealt with cost. Okay? So looks like example 4 is a cost example. Example 3 is an area and perimeter example. Again, your book has extra examples associated with those things. Last thing is going to be example 5. Most of you are familiar with the formula for traveling. Anytime you travel, the distance traveled is equal to the rate multiplied the time. So in America, we're traveling miles per hour. The time is going to be in hours. Okay, as long as it's hours here, it's hours here. If it's minutes here, it's minutes here. Like if we were talking about how fast a meteorite might enter Earth's atmosphere, we might say miles per minute or miles per second. But if we do that, then the time has to also be the same time unit. And distance is going to be the same distance unit. Okay, so wherever you have miles, the other one has to be miles. Wherever you have hours, the other one has to be hours. You can't do hours and minutes. One must be converted so that they're both the same unit type. All right. So time, distance, rate. Here's my example 5. This may seem nonsensical to you, but this type of thinking is going to be useful later. You travel for this much time. Okay, so this is your time. That's your time. And you're traveling at 60 miles per hour. 60 miles per hour, is that going to be the distance or the rate? What do you think, folks? Yep. You are right. So, the question is, how far do you travel? Well, if distance is equivalent to the rate multiplied by the time, what value will we plug in for the rate, Lily? Yep, 60. Is going to be the rate. Good. And what value do we plug in for the time? What value for the time, Kat? Nope, look at it again. That's not what that says. Yep. Look at what it says. Don't ever change it. If it tells you to use this, you changed it from addition to multiplication. It's critical that you do what it says. Little things like that are so difficult to, if you make that mistake, you can't figure it out because you're like, what? It says h, it says 2/3. So this, my friends, is the answer. Distance is equal to 60 times h plus 2/3. Now you're thinking this is nonsense, but it's not. Later you will use this kind of thinking, I promise you. All I'm doing right now is helping you to recognize how to do different things. Okay, so we've done our samples, 3 through 5. And let's do a few items here in the oral, where I was going to start ahead of the game. Page 16, oral. Okay, I'm going to slide it up. Keep copying in your notes. Number 9. This one, is it perimeter, area, cost, or distance? Read it to yourself. Really quick. Read number 9, oral. Is it perimeter, area, cost, or distance? Lee, what do you think it is? She's right. It asks for area. Lizzie, what is the formula for area? Yep. Length times width, which we've always written as L times W. It has a width of 6 and a length of X. Again, it doesn't really matter if you put the 6 here and the X here. We're just representing that the sides, one of them is a 6 and the other one is an X. So, what will the answer be, Kat? 6x. Good. Exactly right. If it's length times width, then it's length times width, which gives us 6x as our answer. Number 10. Read it. What are they asking for? Area, perimeter, cost, or distance, or any piece thereof. And this is going to get trickier here in a minute. Eli, number 10, what is it asking for? It's blank is blank. What's it asking for? Second sentence. Area, perimeter, cost, or distance? It's in the second sentence of number 10 on page 16 in the oral. Right, so my question to you is, what is it asking for? Area, perimeter, cost, or distance? Perimeter, good. He said it's asking for perimeter. It's asking for perimeter, and it specifies it has a width of y and a length of 13. If this one's 13, what is its neighbor across the side, Lee? And if the right side is y, what is the left side, class? All right, let's add all the sides together because perimeter is equal to length plus length, added to width plus width, So what is the sum of the lengths? Yes. And what is the sum of y and y? Bravo. Perimeter is equivalent to double the length and double the width. Ergo, there's your answer. That's perimeter. 11. You travel for da-da-da-da-da-da. Read it. What kind of problem is it? Perimeter, area, cost, or distance? Distance is right. And the formula is distance is equal to whatever the rate is times whatever the time is. Do we know a rate? Might want to look again. It is in kilometers, but it's there. 75, good. 75, and they're telling us K per hour, which means they're using metric. Miles and kilometers are counterparts. Obviously, they're not the same, but they are used the same way. Kilometers indicate miles, like miles, or kilometers indicate distance, just like miles do here in America. And time. Did they give us a time, Jay?
Yeah, T minus 2.
Yep. And since to solve distance we multiply the two together, your end result, therefore, is 75 multiplied by t minus 2. And will I be answering, if I were able to answer, in miles or kilometers? Anybody know? Kilometers, because K stands for kilometers. If it were M, that would mean it's miles. So 75 t minus 2 is going to give us how many kilometers? That's 11. 12. Read it. Something about bagels. Distance, cost, perimeter, or area. What do you think, Lee? She's right. And cost is equivalent to how many you buy multiplied by their cost for each item, right? So I'm kind of summarizing there. What exactly are we buying? Bags of popcorn? Bagels. Lizzie, how many bagels do we buy? Yep. Again, you're thinking, Mrs. Myers, I don't know exactly what M plus 5 is. I don't care, you don't need to. Don't worry about it. Just answer with what they give you. Do they give us a cost, Kat? She's right. Okay. The product of these two is what? Eli, do you know the product when you multiply these two? Jay, you want to help him?
M plus 5
Times.
35 cents.
Yep. Yep. And either order would have been fine, but since I made a bigger parentheses in the second spot, I filled it in there. Okay? Whichever answer you put is totally fine. Here's where it starts to get tricky, my friends. We're on number 13 in the oral. Al earns. What is this similar to? Distance, cost, perimeter, or area? Give it your best guess, Lizzie. What do you think number 13 is similar to? What'd you say, sweetie? Yes, good. So, in other words, what is the cost to employ our friend Al? The cost to employ our friend Al is equivalent to the earnings of our friend Al. So by you figuring that out, you're able to use the formula cost is equal to the count, and I'm gonna bet you the count is how many hours of Al's time we pay for, multiplied by the cost, and that is rate per hour, how much he makes per hour, okay? So, the cost to employ Al. First of all, how many hours did Al work? This is written right in the problem. Eli, how many hours did Al work? Lizzie, you gotta be ready, honey. Lizzie, 8 hours is right. Gotta be ready. We're still in our book. We're not putting it away. What is our rate per hour, Lee?
Well, P plus 3.
Yep. Therefore, the product, which would give us Al's earnings, is 8 multiplied by P plus 3. You can write it like that. You can write it using an extra parentheses, however you like it. Okay? Okay, number 15. The Golden Gate Bridge was built. This is a tough one. N years ago. This one is so tough to picture. 3 years from now, it will be, oh no. Well, yeah, 3 years, it will be how many years old? Okay. Let's look at this from a birthday standpoint. How many years ago, roughly, was Lee born? Okay. Okay. Lee, I'm using this to help us with this. 3 years from now, she'll be how old? How did you figure that out? What did you do to the 15? Added how many?
3.
Okay. So we added the time that is going to pass, right? The bridge was born N years ago. 3 years from now, how old will it be? N plus 3. Good. So, the reason I use birthday, anytime you can equate something with something you could do for real. So, the day something was built is like the day you were born. And you could use your age and add or subtract from it to equate the same situation in objects in life, this being a bridge. Okay, number 16. Number 16. And this is probably going to be the last one I get to, okay? Okay, here we go. A sports arena, okay, maybe I should spell that right. Arena was D years old 15 years ago. This is almost like Lee's age to a T. Now it's how old? Arena was D years old 15 years ago. So 15 years ago, Lee was, I'm going to say 0. Right? Now she's 0 plus 15, right? So this is Lee. Let's go to the arena. What do we know about the arena? 15 years ago, it wasn't 0, it was how old? How old was it 15 years ago? D. Now. So if it was 15 years ago, it was D. Now how old is it? D plus 15, good. These are some of the most difficult ones, which is why I highly recommend, that must be about volleyball, why I recommend using a real world example, and then equating it with the object in question, okay?